Hey everybody, so today we're going to be talking about simplifying trigonomic expressions. I'm going to kind of walk you through the process. We're going to do 4 or 5 example problems, then you're going to have 4 or 5 problems to do on your own. So to start with, I guess, what does simplifying a trigonomic expression mean? Well, it means It means rewriting them so that only 1 or 2 trig functions remain or that they cancel out to make an integer. If you notice what's at the top of this note sheet, sorry, my iPad's kind of jerky right now, is you should have your trig relationship sheet handy when you're going through this. It's going to make your life a ton easier. That's why we spent time yesterday going through and getting used to rewriting and recognizing some of these relationships. I do have a few helpful hints for you. And if you notice, I wrote 1, 2, the same thing 3 times. That's going to be the name of the game. Rewrite and cancel. Rewrite, cancel. Rewrite, cancel. Rewrite, cancel. So what do I mean by rewrite? Well, what you want to do is you want to get everything in terms of sine and cosine if possible. Why sine and cosine? Well, remember that sine and cosine, well, here are our trig functions. We have sine, cosine, tangent. Should be okay with that. After sine, cosine, and tangent, what else do we have? Well, we have cotangent, we have secant, and we have cosecant. Now, why do we want them in terms of sine and cosine? Well, if you remember, what is tangent equal to? Tangent equals sine over cosine. So that means if everything's in terms of sine and cosine, we can then simplify it down to something smaller. Cotangent we can rewrite as cosine over sine. Cosecant is 1 over sine, and secant is 1 over cosine. So we want to rewrite everything in terms of sine and cosine because each of these has at least 1 or cosine involved with them. Okay? You also need to perform any operations. Now, this is going to be a big one. Sometimes you're going to want to add or subtract when really you need to multiply, and more specifically, you're going to need to FOIL some things out. We'll do a problem like that today. The common denominator portion, that is going to be more tomorrow, so I'm going to put a star by that and kind of skip past it. Same with factoring. Okay, so the name of the game, like I said, guys, is going to be rewriting factor, rewrite, factor, rewrite, factor, and rewrite, cancel, rewrite, cancel, rewrite, and cancel. That is the name of the game today. Okay, so first example says sine of theta times secant of theta times cotangent of theta. And again, we want to rewrite everything in terms of sine and cosine. So first of all, we have sine of theta. Well, that's okay because it's already in terms of sine and cosine. Secant of theta, you should know you can rewrite secant as 1 over the cosine of theta. Last but not least, we have cotangent. You should know that you can rewrite cotangent as cosine of theta over sine of theta. And again, these are ones that we probably know from before the shutdown, but they're also on our trig relationship sheet if we forget. So now we have the blue one is in a fraction. So what we need to do is just put it over 1, make it a fraction. And now we rewrote them. Now we need to cancel. Rewrite, cancel, rewrite, cancel. So is there anything that's on top and on bottom? Well, you should be able to see, well, I have a sign on top and a sign on bottom. Since I'm multiplying between each fraction, I can just cancel those out. Same with cosine on top, cosine on bottom. Again, I'm multiplying, so I'm just pretty much cross-reducing. Now all that's left is 1 over 1. You should know that 1 over 1 simplifies down to just 1. 1 is your final answer here. Okay, on to number 2. Now, number 2, none of this appears on our trig function sheet. If you remember yesterday, there was the Pythagorean identities. These are similar to the Pythagorean ideas, but they don't have the squared right there. So I am not able to rearrange my Pythagorean trig identities. So what I need to do actually is just see what operation am I doing here. Am I adding, subtracting, multiplying, or dividing? Well, since we have two binomials here, two parentheses with two terms each, what I need to do is FOIL. There's no add or subtract sign. That means multiply. So let's FOIL this out. We're just treat them like numbers. So what's 1 times 1? 1. 1 times sine of theta is plus sine theta. Negative sine theta times 1 is minus sine of theta. Negative sine theta times positive sine theta is minus sine squared of theta. Okay, so now what you should see is, well, right here, plus sine theta minus sine theta, those cancel. So I now have 1 minus sine squared theta. Now, I hope that you have a bell ringing in your head. Ding, ding, ding. Ooh, I have something squared. That means I should look at my trig functions sheet and look at the Pythagorean identities. One of the Pythagorean identities is sine squared theta plus cosine squared theta equals 1. Now you should be asking yourself, well, since I have a sine squared theta in my problem and there's a sine squared theta here, can I make the yellow star look like the green star or vice versa? Well, how do you get 1 minus sine squared theta here? Well, all you need to do is minus, I'll change to a pen, minus sine squared theta minus sine squared theta. These cancel. You are left with cosine squared theta equals 1 minus sine squared theta. Now you should notice, hey, this looks the exact same as this. So what does that mean? This whole thing reduces to this right here, cosine squared theta. That's your final answer. Again, yesterday we rewrote these in a few different forms. We just rearranged the the Pythagorean trigonomic relationships so that we can recognize that, hey, this is the exact same thing as this. So what I'm boxing right now in yellow, that would be your final answer. Okay, on to number 3. 1 second quick. Okay, on to number 3. Here we have sine of theta times tangent of 90 minus theta. Again, right away, you should be having something go off in your head. Ding, 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 ding. Why? Well, what we have here is a specific trig relationship. You should understand and you should notice right away. Again, I don't expect you to memorize what it actually says, but you should notice that this is on your trig sheet. So on your trig identity sheet, what does that simplify down to? Well, tangent of 90 minus theta, that simplifies down to cotangent of theta. This stays the same. So now I have sine of theta times cotangent of theta. Okay, so we rewrote that trig identity, and now, again, we want to get everything in terms of sine and cosine. So cotangent of theta, or just cotangent, what is cotangent? Well, cotangent is cosine of theta over sine of theta. This stays the same, sine of theta times cosine over sine. Well, this is really sine of theta over 1. Now, can I cancel anything? Is there anything on top and on bottom? Well, sure. There's a sine on top, sine on bottom. What are you left with? Cosine of theta over 1, which is just cosine of theta. Bingo, bango, bongo. Love it. Okay. Number 4. On number 4, again, we want to get everything in terms of sine and cosine. So the top is already cosine and sine. The bottom, you should be having a ding, ding, ding in your head. Why? Well, we have a sine squared theta. What does that relate to? That relates to the Pythagorean relationship. So it is sine squared theta plus cosine squared theta equals 1. So I want to get this to look like this, or vice versa. So how can I get 1 minus sine squared theta? Minus sine squared theta. Minus sine squared theta. These cancel. You now have cosine squared theta equals 1 minus sine squared theta. Now, you should realize that this is the same as this. So what can I do? Put cosine squared theta in place of this. So now I have cosine of theta times sine of theta over cosine squared theta. So what the heck does that mean? What's cosine squared? Well, cosine squared is really, well, let's back it up. What's 3 squared mean? 3 squared is 9. Well, yeah, that you just have that memorized, but how do you get 9? You get it by 3 times 3. So what I'm saying is, I'll write it up here in green. 3 squared is 3 times 3, which is 9. So that means cosine squared theta is cosine of theta times cosine of theta. So let's rewrite that. Cosine of theta cosine of theta times sine of theta. I got to erase that. Cosine of theta times sine of theta over cosine of theta times cosine of theta. Well, you should see now, hey, there's a cosine on top, there's a cosine on bottom, and I'm left with sine of theta over cosine of theta. Well, can we simplify that down even further? I know I said that we want to get everything in terms of sine and cosine, but at the very end, if we can get 2 terms, we have 1 term on top sine, 1 term on bottom cosine. If we can get 2 terms to look like 1 term, we always want to do that. Make it as simple as possible. So if you look at the top of your trig identity sheets, you should know that sine over cosine equals tangent of theta, and that would be your final answer. Okay, I will post the video of this along with a screenshot of this section of notes along with your assignment for the day. If you have any questions, please feel free to email me and continue to submit your work via Google Classroom.